Okay. So we'll be moving on to the next section, next section of the chapter. So today we'll be dealing with rates of change, and it's sort of iffy or complicated. So just today we're going to be finding rates of change. And what that is a ratio that compares the amount of change in a dependent variable. Oh my goodness. So the amount of change in a dependent variable to the amount of change in an independent variable. Independent. Let me make sure I'm spelling right. So someone first tell me what's a ratio? Right, so fraction, and what do ratios do? Yes, Claire? No, that's a power for exponents. But yes, Julia said that ratios compare, and that's exactly what they do. So it stands to say that rates of change, since the ratios are going to compare two things, and it says right there, an independent variable or dependent to an independent. So if you guys want to turn to page 244 in your book, we'll be doing check it out. Tori, can you read that problem for us, please?
The table shows the balance of a bank account on different days of the month. Find the rate of change for each time interval. During the time interval, did the balance decrease at the greatest rate?
All right, thank you. So we're given a table of values, right? Are we? Yes, we are. Good. So first things first, we probably want to graph our points because they tell us to. So before we can do that, why? Okay. So we have a graph there. Is it numbered all the way out? Nope, so we have to do that. And what's the x-axis scale going by?
Twos.
Yep.
Oh, sorry, just kidding, that's a lie.
Right, so the x-intercept is going by twos, even though the number showing is going from 4 to 8, they're still skipping that grid line, so every grid line is going by 2. So you guys can number that, and I'll do 2. 18, 20. Those are awful numbers.
You're skipping over.
Yeah, that's completely messing up. 20, 24, 28, 32, 36, 40. Oh. So we numbered our x-axis. Now we have to number our y-axis, and what's that scale going by? 25, right? Since they're skipping a grid line going from 150 to 200. So every 2 grid lines is 50, every one is 25. Exactly. So you guys can number that one. All right. All right, so once we have our axes numbered, right, the problem tells us to plot each point and connect points with line segments. So for number 1, 550, where would number 1 be on our graph there?
The 2 is right before the 4, so just like over before the 2.
So like halfway in this first box, right? Right. So we go 1 and up to 550, and my numbers are in the way. 550. So number 1 is right around there. Okay. So then we have 6, 285, so 6 would be in between 4 and 8. And then 285, 275 is between 250 and 300, so that'd be just above it. So like right there. And then you just keep doing that with all your other values. So 16 is 210. About right there. 2 is 210. Looks like everyone's got their points plotted. So, if everyone has their points plotted, does everyone's graph look like this? 1 point just going down like that. So, the next thing we have to do is connect the points, and now we just play connect the dots. So when we're talking about rates of change, we're talking about how quickly things change from one value to another. So when we are dealing with this one, we'll be comparing how fast the balance went from day 1 to day 6, day 6 to day 16, day 16 to day 22, and then so on. So to do that, what do you guys think would be a good comparison to make? Would it, Cody?
Don't you, to make a quick comparison, wouldn't you need to use your run and your rise?
And what do you mean by that?
Like, you use your rise to find your y, the difference in your y value of 2 points in a line, and you use your run to find 2 different, or the difference in x values of 2 points in a line.
Yep, you can do that. So, we want to find the difference between our 2 y values, and what's our y value for this problem?
That would be 550 and 285.
Exactly. So, to do that, we find the difference. We just, and I'm still making lines, so that would probably help if I wasn't doing that. So we have 550 minus 285. And we're dealing with ratios, right? So we have to have comparisons in fractions, right? So to do that, we would divide this by the corresponding day values or x values that go with it. So since 550 is first, the 1 would have to go first. And then we just subtract the next x values. So So what is 265 divided by -5?
Negative
Negative 50. All right, so we're comparing things, right? So what does that mean, 53?
Did you say 53 or 2?
I said negative 253, but I meant negative 53.
Right. So, if we have our balance on top, what's that label? Or what is the y values label?
Balance,
Or
total balance,
dollars, right? So we have dollars. And then what's our label for our x values?
days.
Days. So that negative 53 right there, that is the rate of change that happened from day 1 to day 6. It went down negative $53 each day to get to 285.
That's all you do.
More or less, yeah. We're comparing to see where the biggest rate of change is, right? Because that's what the question's asking for. So, we've only found one. We still have to find 3 more. Yeah.
Okay, where's that represented on the graph class? Where's that negative $53 per day? Where's that represented on the graph?
When it goes backwards, or not backwards, but like down.
What's it?
Yeah.
The line,
The biggest,
The line. What line?
the
the,
biggest one.
the line
Let's
from,
talk about them in their order, going from left to right. Which one? Which line segment is it?
550 to 285.
Yeah, so the first line segment, correct?
This
The one that looks the steepest? Is that what you're trying to say goes down the fastest? Yeah, the steepest one? Okay, so there's what you just found. You found out that that is a negative, represents a negative $53 per day, a drop in the account of an average of $53 every day.
Yes, Michaela.
Okay, so the question right above what we just did, it just asks the decreases of the greatest route. Wouldn't that be this one? Negative 50.
According to what, Michaela?
According to this, the lines.
Yeah.
Mhm. So since this is the steepest line segment in our graph, that means that that particular section has the greatest rate of change. So that would be correct. So the balance decrease at the greatest rate from day 1 to day 6. So that's what we just found there. But we still have to find the rates of change for all these other days. So let's
Not the intervals.
intervals, excuse me.
3 more funny.
3 more intervals. All right, so from day 6 to day 16, we have our 2 y values or balance values. So we have 285 minus 210. Then we have 6 because 285 is paired with 6. So they're going first. So looks like everyone got the same answer for the second interval, day 6 to day 16, of negative $7.50 per day. So what does that represent for that interval? That from day 6 to day 16 is went down at a rate of,
Negative about $7.5 a day.
right, so from day 6 to day 16, every day it lost $7.50. Okay, so let's do day 16 to day 22. I'm sure, so what were the numbers for that one?
210 minus 210.
Okay,
160 minus
16 minus 22. Alright, so we have 0
Or negative 6.
over negative 6. So that's 0, and then our rate is
$0.
$0 per day, right? So if we look at the graph, that interval is right there, those 2 points. So there's no change in the y value, is there? It just goes straight across. So that's where that, it's staying the same even though time is going forward. So for that interval, $0, it stays the same for 6 days, right? Alright. Now, last one, we have, we can scroll down. What were the values for that one again?
220 minus 175.
That's 175,
22 minus 30.
22 minus 30.
It was 35.
35.
That's negative 5.83.
Negative what?
5.83.
Negative 5.83, is that what everyone else got? Okay, so Michaela got negative 4.375.
Okay, yep, I accidentally divided by negative 6.
Alright. So Michaela got minus 4.375. But we're dealing with dollars, right? Do we have hundreds or thousands of dollars?
No, so it would be
30.
negative,
No, 30.
negative
0.4.
Hmm?
Would it be 0.4?
Well, can we have hundreds of dollars?
It would be negative 4.4 or negative $4.40 or 40 cents.
Can we round that a little easier? To the hundredth value, maybe?
38.
Negative
Negative
4.38
cents.
Right, because we can have hundreds of dollars, right? We have pennies. So this means that it's decreasing at a rate of negative 4.3 or $4.38 per day. All right, so what we just found, if this thing wants to cooperate. Okay, so we just found the rates of change for each of these intervals. So the first one, it was minus $53 a day. The second one, negative $7.5 a day. The next one, 0. And then the last one was minus 4.38. So when we find rates of change, we're still finding comparisons. That's what ratios are, right? So we're just comparing the decrease in dollars, or decrease or increase, depending on which way the graph is going. We're just comparing what the change is in our y value to the change in our x. So, does anyone have any questions before we move on to the other page? Okay. Next. So it says this table shows the average temperature in degrees Fahrenheit for 5 months in a certain city. Find the rate of change in temperature for each time period, which is kind of what we just did on the previous problem, except we were dealing with dollars, right? So during which time period did the temperature increase at the greatest rate? So we have our graph. Is it numbered all the way? Nope, so we have to do that, right? So what's our x scale going by? 1. So we number each one. I'm going to do every other one because just to save space. And what's our y-axis going by? What's its scale?
4, but you're switching every 2.
Yeah,
It's going every 2 blocks, but it's going by 2s.
Okay, so the scale is going by 2, but our numbers are going by 4s. So, good catch on that. So, our scale is going by 2, so then we just keep on trucking along with it. So once everyone has their graph's number, we can plot our points, right? So our first point is month 2, and the temperature was 56 degrees, so we just go over to month 2 and find, whoops, that's not right. All right, yeah, it was. Okay. And just keep on going, 356. 63. 771. And 872. So once everyone has their points plotted, we just do connect the dots, right? So we go from 2 to 3, that one. Here we go.
According to how many line segments there are, how many rates of change did you have to find? How many rates of change?
4.
4.
Mhm.
4 line segments, therefore there are 4 intervals
There's one.
to find the rate of
2.
change for.
All right. So just from this graph, which one do you guys think would have the greatest rate of change?
Those two are kind of even.
Right, they look really similar, don't they? So we can't really tell just from the graph, right? So that's where our calculations come into play, so we can actually find exactly which one does have the greatest rate of change. So, just like we did on the other side, we have our, what's our Y value? Temperature, right? So that one goes upstairs, so we have 56 minus 2 minus 3. So what would our label be for our ratio that we just found?
It's Fahrenheit per month.
Right, so it would be 0 degrees Fahrenheit per month. Quick question, would it make sense if we had the label month per degrees Fahrenheit? No, that wouldn't make sense, would it? We can't say like, oh, it changed 2 degrees a day, it must have been 2/10 of a month, right? That doesn't make sense, right? So, that's why we have our dependent variable on top, because that's what we're trying to find. So that's our, why we have y, our y value upstairs, and our x value downstairs. So,
So sometimes you have to make the decision from a table, where there's not a graph there for you. You have to make the decision, how should the rate of change be labeled? Does it make more sense to say miles per hour or hours per mile? If you put hours upstairs, what would you end up with? You put hours upstairs and miles downstairs, what would your answer tell you?
1 degree.
No, I'm this is not even this table. If we were working with another table and we were working with hours and miles, and we had hours upstairs and miles downstairs, our rate of change would be hours per mile, right? So would we then have to say, I did not set that up right, I should have put the miles upstairs and the hours downstairs, so I get miles per hour instead. Have them quickly work these last three on their own here.
Okay, so next three you guys can do on your own. Alright, so most everyone's done doing this, so we found the rates of change for our four intervals, that's what we decided there would be, right? So for the first one, it was 0 degrees per month. Next one was 3.5 degrees, the next one was 4 degrees, and then the last one was 1 degree. So based on this, what interval or what?
5 and 7.
5 to 7. So for this one, the temperature increased at the greatest rate from month 5 to month 7. Now we know for sure that during this interval, this one right there, that increased at the greatest rate. Does anyone have any questions about rates of change or anything? All right.